So hello guys, so nice that you are linked to this session, to this lecture. Today it is about hematological neoplasms. All the term is malignancies, but neoplasm is a better term because it talks about also not so malignant stains or whatever. So let's start. Today's theme is hematological neoplasms. The term neoplasm is more general. It is, obviously. And what is the flight plan? So flight plan. So first, and as it is typical with me, we're going to go through some terms, okay? So we're going to go through some important terms. And also, let's say, some general principles, okay? So I will try to tell you some general things you would expect in this case or that case, whatever, we'll see. So if we're going to do terms, there are going to be many. It's going to take a while, but I'm putting you on our same start, and then we'll use these terms and whatever to go through the other parts of the lecture, okay? So the second, we're going to do myelodysplastic syndromes. So we're going to go through that. Then third, we're going to do myeloproliferative syndromes. Or we're going to do myelodysplastic syndrome and myeloproliferative syndromes, or today it is better to say myeloproliferative neoplasms, okay? Then we're going to head to AML. So at 4, we're going to get to AML, so acute myeloid leukemia. And in 5, because we're starting today, and the main thing and everything you're going to hear about mutations, whatever, you should orient for myeloid lineage. But at the end, I hope we'll have enough time. I'm going to still mention something about acute lymphoblastic leukemia / lymphoblastic lymphoma, which is today, according to WHO, it's one entity. We put it together. There's the same genetic but bit different clinics, but it's one entity, okay? So first of all, let's jump to the first term, okay? And the most important definition for today is a definition of leukemia, okay? So leukemia, or to be more precise, acute leukemia, acute leukemia definition. And as you all know very well, we got AML, so acute myeloid leukemia, and again, acute lymphoblastic leukemia / lymphoblastic lymphoma. Okay, so now we're going to focus on ALL over here in AML. And in both cases, although with AML it's like straight away direct, the definition is the amount of blasts in the bone marrow. So if you do a bone marrow puncture or whatever, normally you should have below 5, or some say below 2%, or some say 5%, doesn't matter. Anyways, every time the blasts, and it doesn't matter if it's acute myeloid leukemia or if it's acute lymphoblastic, every time they reach over 20%, you can talk about leukemia. Okay, that's a very important point for today. So if I will write it over here for the myeloid lineage, so the bone marrow, the amount of blasts has to be over 20% to talk about acute myeloid leukemia, and the same in bone marrow blasts, it should be over 20 for, that should be lymphoblasts in this case, lymphoblasts, and this should be myeloblasts. Okay, so if they reach over 20%, it's leukemia according to WHO. With the blood levels, it's different, and I'll explain it maybe now already. It always depends, because in leukemias typically, and in both, I mean, we're talking about acute leukemias now. So in acute leukemias, 1/3 of the patients, they can have lower amounts of leukocytes, 1/3 normal, and 1/3 higher. So the level in blood is not the most important thing. Of course, if you're going to have so much lymphoblasts or myeloblasts in the bone marrow, then you should expect that there should be high levels also in blood. Okay. And on the other hand, if the percentage in blood is really, really high, of course, of the blast, you're having leukemia. Okay. But the place which tells you, obviously, or the cutoff thing, or the cutoff for acute leukemias is the percentage in the bone marrow. Okay, that's an important message. Okay, so in blood, of course, if you're going to have in blood myeloblasts over 20%, yeah, it's going to be leukemia. And the same accounts for lymphoblasts. Okay, yeah. Okay, but the important place is the bone marrow. Okay, and bone marrow puncture. Okay, so that's very important for today in terms of acute leukemias. Okay, so that's point one. Point two. Point two is myelopoiesis versus lymphopoiesis. So myelopoiesis versus lymphopoiesis. And I want to stress a few things over here. And there's a big difference in terms of myelopoiesis and lymphopoiesis. So what I'm going to draw over here is a vertebra. Okay, you should all see a vertebra now. I'm going to slide it up. Sorry, I want to keep 100%. Okay. And the reason why I'm drawing vertebra over here now is to remind you it's about bone marrow. Okay. But anyways, if we would anatomically talk about the production, we shouldn't forget about pelvis. That's a big place, or is the hugest place of hematopoiesis, but don't forget also the femur and its upper part. There's a big production, and of course vertebrae as well. Okay, but I'm going to draw a vertebra because it's a nice, the shape is good that I can draw in it. Okay, so don't forget vertebrae are also a very important place of hematopoiesis. And what's important over there? Well, it's the hematopoietic stem cell, of course. So it's here. And basically, the hematopoietic stem cell lives in two phases, or it's like sleeping. It's dormant. One part is dormant. There are two places that we know. You don't need to know which ones, but there's a place where they sleep, so they're dormant, and then there is a part of them that is active. And it's pretty striking that we got only a small number of hematopoietic stem cells. It's like some papers say like 50,000 till 200,000. So we got only a few hematopoietic stem cells, and most of them are rather dormant, and still we're able to produce such a vast and like really huge amount of blood elements every day. Okay, of course it's thanks to the cascade as they multiply doing the cascade. Well, we know, for example, that to produce a erythrocyte you need at least 8 divisions. Okay, so this hematopoietic stem cell, the ones that produce are living in a perivascular space. You call it a perivascular space, and they're typically CD34 positive. Okay, and what's their feature? They're able to multiply like unlimitedly. So they'll multiply all the time, and then their children, which are produced, then they divide into two ways, in the way of myelopoiesis and lymphopoiesis. So I'm going to draw it over here. Of course, I'm going to simplify it very much. But now let's talk about myelopoiesis. And that's myelopoiesis. And with myelopoiesis, it's pretty straightforward because all the stages of maturing of the cells in this lineage is placed in bone marrow. That's very important. Okay, so if we're going to go, I'm going to, of course, very much simplify it, but then the cascade goes to common myeloid progenitors. So common myeloid progenitor. We could name it as myeloblast. Okay, and then of course these divide into erythroblast, then myeloblast, then megakaryocyte, and then monoblast. And of course, the erythroblast then forms a erythrocyte at the end. Myeloblast forms neutrophils. So all the granulocyte neutrophils, basophils, eosinophils. Megakaryoblast creates megakaryocyte. Today, pretty importantly, when we're gonna talk about myeloproliferative syndromes, and this shades the cytoplasm, so we got platelets. And with monoblast, of course, then monocytes. And with monocytes, a comment over here, don't forget, of course, monocytes, then they become later in the tissue macrophages, but also don't forget a special way where you, through this, let's say, lineage, you can produce dendritic cells. And by the way, with dendritic cell, it's not important for today nor next time, but they can be created like through 3 ways, like directly from, there's a, let's say, a shortcut from the myeloblast, and also don't forget, we're going to have on the other side lymphoblast, so also from the lymphoid part, you can make dendritic cells as well. So, okay. So this is just to remind you the myelopoiesis, and the main point of today is the whole myelopoiesis is placed in the bone marrow. So all the elements from the myeloid side, when they enter the bloodstream, they are fully matured and they mature in bone marrow. That's important. So also, if there are any mutations, and if I want to generalize over here, if there are any mutations within the myeloid lineage, then of course there's a connection with bone marrow failure. It can be, okay? Because it's the place where they're generated. So if there's a mutation, and if the mutation is pretty high in this, let's say a tree or whatever, or this spider web, then there are going to be problems with hematopoiesis, okay? Or bone marrow failure. If we swap to lymphopoiesis. So, thanks for watching, and don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.